So here's a quick introduction to how to do trigonometry. There are two special right triangles that we're going to talk about today. One of which is the 30, 60, 90 right triangle, and then the 45, 45, 90 right triangle, which will help you begin your understanding of the unit circle. So the first thing is with the 30, 60, and 90, there's a ratio that their three sides across from each angle are always in this ratio. Opposite 30 is a 1. The hypotenuse, or opposite 90, is always double that. And then opposite 60 degrees, compared to opposite 30, is radical 3 times that. So they are in the ratio of 1 radical 3, 2. It's not 1, 2, 3 the way that the angles are. It's 1 radical 3, 2. You can prove this by Pythagorean theorem. 1 squared plus radical 3 squared is 1 plus 3. The square of a square root cancels, and that's equal to the hypotenuse squared, which is 4. So 1 radical 3 and 2 are the ratio of their three sides. Now, hopefully, you're pretty good with the sine, cosine, and tangent as far as SOHCAHTOA. The sine of any angle is the opposite side divided by the hypotenuse. The cosine is the adjacent divided by the hypotenuse. And the tangent is the opposite over the adjacent. So opposite 30 over the hypotenuse says the sine is 1 over 2. Adjacent to 30 divided by the hypotenuse is the cosine of 30. And opposite over adjacent is 1 divided by radical 3, which is not simplified. It has to be rationalized, so we multiply the top 1 by radical 3, and then when we multiply radical 3 by radical 3, it becomes just 3, the square of a square root. Radical 3 times radical 3 is radical 9, or 3. Now we can skip and do the same thing for the sine, cosine, and tangent of 60 degrees. The sine of 60 is the opposite over the hypotenuse, so the opposite of 60 is radical 3 over the hypotenuse, which is 2. The cosine of 60 is the adjacent, which is 1, divided by the hypotenuse, which is 2. This should always be the case. If two angles are complementary, which means they add to 90, the sine of one is the cosine of the other, because the opposite and adjacent switch places when I change which angle I'm talking about. Also, for the tangent, the opposite and adjacent switches. So the opposite divided by the adjacent would be radical 3 over 1, which is just radical 3. So the sine, cosine, and tangent of 30 is 1 over 2, radical 3 over 2, and radical 3 over 3. For 60 is radical 3 over 2, 1/2, radical 3. For 90 degrees, it doesn't matter which triangle we use. The sine of 90 is the opposite, 2, divided by the hypotenuse, 2, which is 2 over 2, or 1. The cosine, well, there's two adjacents. You can't just choose one. So the cosine of 90 actually doesn't exist. It's 0. Well, it's 0. It doesn't exist because we have two adjacents. Now, another useful way to find the tangent, besides opposite over adjacent, is it's the sine value divided by the cosine. So if I did 1 divided by 0, that would be undefined. So for tangent of 90, it's non-existent. So all of these three numbers, 1, radical 3, and 2 for 30, 60, 90, are the 30, 60, 90 sine, cosine, and tangent. Now, with our other special right triangle, the 45, 45, 90, one of the ratios is 1 to 1 to radical 2, or radical 2, radical 2, 2. So opposite 45 are the same length. It's the right isosceles triangle. So it doesn't matter which 45 we choose. Opposite 45 is radical 2 divided by the hypotenuse for the sine. So that's radical 2 over 2. The cosine adjacent over hypotenuse, radical 2 over 2. Opposite divided by adjacent, well, radical 2 divided by radical 2 is 1. We now have all three sine, cosine, tangent values for the 30, 45, 60, and 90. Now, another way to talk about the sine, cosine, and tangent is the sine value is the y value on the unit circle, the cosine is the x value, and the tangent, which is sine divided by the cosine, makes this y divided by x. The cosecant is the opposite of the sine, which would be the opposite of the y value. So if I take each sine and flip it over, the cosecant of 30 is 2 over 1. The cosecant for 45 would be, flip it over, 2 over radical 2, which I rationalize by multiplying radical 2 times the top, so 2 radical 2. Multiply the bottom by radical 2, so it becomes 2, and that cancels to give me just radical 2. If I flip this over, I would get 2 over radical 3, which rationalizes to 2 times radical 3 all over 3. And flipping over 1 is just 1. The secant is the cosine flipped over, so it's the opposite of the cosine, or the opposite of the reciprocal of x. So radical 3 over 2 flipped over, which is the same thing as this value from before, is 2 radical 3 over 3, radical 2, 2 when I flip over my cosine. Now when I flip over 0, I would have 1 over 0, which doesn't make sense. So the secant of 90 is also undefined, since I can't divide by 0. Cotangent flips the tangent over. So before I had 1 over radical 3, I would flip that as radical 3 over 1. Flipping 1 over gives me that for the cotangent of 45. Flipping over radical 3 gives me 1 over radical 3, which was the tangent of 30, becomes radical 3 over 3. And because this was 1 over 0, when I flip that over, I get 0 over 1, which is 0. And the cotangent is the opposite of the tangent, so that is actually x over y. That is now all 6 values of our 30, 45, 60, and 90 degree angles.